dependency management, right? Doron, tell us a bit about why dependency management is more complex in microservices versus like a standard kind of monolith.
So usually when you got a monolith, you have a central. I mean, you more or less have central place where when you manage. It depends how you work. If you use a BOM, for example, with Maven or even with Gradle, you manage your dependencies pretty much centrally, and you have the dependencies for your monolith. Usually, you can have a monolith with many submodules, but still, you more or less you can even have some dedicated people that manage dependencies. But microservices are more decentralized because we want to give freedom to the owners of each microservice to actually decide which dependencies they want to use. They can add dependencies when they want to, as long as the dependencies are compliant and have no vulnerabilities. They can add. So there is no one place where we can actually go over and see what are all the dependencies that all the microservices are using, and they can bring different versions of the same dependencies. And we also have common libraries, and sometimes it creates conflicts, and you're not sure which dependency version of a specific library a certain service is using, and so it creates a bit of a harder situation to monitor.
And that's a great segue into this next example you're going to share with us. And I'm just explaining folks kind of what they're looking at here. Once again, this is a build scan, right? We're looking at this integration test that failed. This red means kind of this was failure. And by the way, folks, all this stuff that we've blurred out here, it's not bad resolution from your GoToWebinar. This is actually to hide some of the things that are specific to Doron's project and whatnot. So you're looking at a build scan here. We're looking at the console log, right? So Doron, as you mentioned, right, bad folks using the wrong dependency versions. Tell us about this example of what's going on here.
Yeah, so what we're looking on is a build scan, right? So when you got a problem in the build, then you want to start investigating it. So Gradle Enterprise is actually pretty helpful because it lets the different members of the team can collaborate more easily about a specific problem. So this is just one case study that I chose because there are many problems, things change, things break all the time. But this is a bit complex but interesting case study. So somebody told me that the build started to break on CI for a project that did not have any code changes recently. So a few hours ago, the build succeeded, and now it fails constantly. No code changes, not today, not yesterday, not recently. How come the build started failing? So what I saw is this console output, again, in Gradle Enterprise Build Scan, which can show me a lot of information in the UI. I don't even have to try to reproduce the problem on my own local machine. I can see the problem right away. It's there, and I can see all the different information about the build. I see a stack trace that says no such method error, coming from a micrometer from a library called Micrometer. So if you have some experience with Java development, you probably think, probably you have something wrong in the class path. Probably you have a wrong dependency of something in your class path. So that's the direction that I was thinking about. So if you go to the next slide, what I did basically is, again, I did a build comparison, just like we saw before. I compared between the build that succeeded a few hours ago and the build that now just failed. The build that just now failed is on the left side actually, and the build that succeeded is on the right side, the green one. The blue one is the recent one, and I see that dependencies have changed. I see that for the newer build, we have some sort of a client library that we get, that it's a dependency on a client library version 38, but a few hours ago, we had a dependency on version 37. How can this be? I mean, if nobody touched the code, nobody touched the dependencies of this project, how come the dependencies have changed? So right now, it was still a mystery for me. So what I had to do is go and see the specific dependencies of the recent build. Here, what I saw is that the recent build that failed, you can see on the top, it's in red. It means that this build failed. There's also an X. What I can see is that it was trying to resolve it has a dependency. It has a dependency on micrometer core 1.5.5. That's what it requested. But it resolved 1.1.18. That's because of the dependency rule. Sometimes builds are configured to bring to force a specific version. But the important thing is that it requested 1.5.5. You see that the build that succeeded before it started failing was requesting version 1.0.4 of the same library. So it was requesting an older version of micrometer, and it succeeded. So again, this is a pretty complex issue, but I could debug everything just by looking at the UI and understand everything in about 20 minutes without trying to reproduce the problem. And you can see the conclusion. So what was happening here is that our code was compiling against an older version of micrometer. It was compiling against version 1.0.4, which was still compatible with 1.1.18. But when our code was compiling against a newer version, it started to fail. And that's because there was a method that didn't exist in the older version. So it was trying to use a method that doesn't exist in the class path, because in the class path, it gets the older version. That's why you got the no such method error. So this was just an example of how you can investigate a problem which is pretty hard to debug and to find the root cause of. And I could do it without even trying to reproduce it on my own laptop. I could just dig into the details here in the build scan.